Okay, next video, we're doing function notation and evaluating functions. All right, so coming to this first part right here on the function notation box. So what we see, it says y equals 4x minus 1. So the function notation on this, really all you're doing is you're taking out the y and you're putting in f of x. So I hope everybody understands this. F of x and y are the exact same thing. It's just that when you're doing function notation, meaning you're plugging in numbers for x, they like to use f of x to show that you're actually plugging in numbers for x. All right? F of x and y are the exact same thing. And it could be different. The first letter could be different. You could have g of x. You can have a of x. You can have b of x. It does not matter what the first letter is. It's really irrelevant. Okay? Whatever that letter is of x is the same thing as y. Literally the exact same thing. How does it read? It reads f of x equals, and then obviously whatever your equation is, which in this case it's 4x minus 1. All right? So in the next box, x is the independent, which I've already gone over that. X is always independent, meaning you can plug in whatever you want for x, okay? And then f of x, which is the same thing as y, and I've already gone over this, okay? Y is independent, y is the dependent variable. So if f of x and y are the same thing, then f of x is going to be the dependent variable. Also, the independent variable is your input, meaning you're putting the number in for the x. That's why they call it input. You're putting in the number for the x, which spits out a number, which is your output, meaning it puts out a number. So the independent variable x is your input. The dependent f of x is your output. All right? So let's go to this example right here. So we've got, if f of x equals 4x minus 1, find negative f of negative 7. So the negative 7 is in place of the x. So it literally wants you to put it in place of the x. Pretty simple. I mean, if it's f of x and they replace the x with a number, then you put the number in place of the x. So this is going to be f of negative 7 equals 4 times negative 7 minus 1. Now, the left side, f of negative 7, is still the same thing as y. I know that's weird that f of x is the same thing as y, but all it's telling you is f of negative 7 is still going to be your y. All right? So you're not going to use the left side here, meaning literally the left side you're just going to drop down. All right? So what it's saying is when you plug in negative 7, what does the equation equal when you plug in negative 7 for x? So obviously, here we're going to get negative 28 minus 1. Our answer is negative 29. So my y is going to equal negative 29 when I plug negative 7 in for x. All right, so let's do some more. So right here, what it's wanting to know, what is your answer when you plug 5 in for x? All right? And again, the left side, you're literally not doing anything. All right, it's the right side that you do all the math. So obviously that's pretty simple. So f of 5, when you plug 5 in for x, the answer is 12. All right, number 3. It wants to know what is the answer when you plug -3 in for x. So it's going to be g of -3, and then literally you just take out the x, put in the -3. So when you plug -3 in for x, your answer is going to be -17. All right, next one, number 3. Okay, what it wants to know the answer when you plug 9 in for x. So it's going to be h of 9. And again, the left side, you don't do anything, okay? It's just saying, hey, I'm plugging 9 in for x, all right? What does it equal? So the right side is where you're going to do all the math, all right? So 2/3 times 9 is 6. 6 minus 1 is 5. And that's your answer. So when you plug 9 in for x, the answer in this equation, the answer is 5. Same thing. We've got 2 x's this time, so it doesn't matter. When it wants you to plug in -4 for x. Whoops. Try that again. It wants you to plug in -4 for x. So it's going to be f of -4, and then take out the x, put in a parenthesis, put the -4 in, take out the x, put in a parenthesis, put the -4 in. Pretty simple, okay? So remember, when you have a negative number inside parentheses squared, it turns out positive. So this is going to be positive 16. And then when you minus a negative, it actually equals a positive. So when you plug in -4 for x, your answer is 20. All right, the next one. It wants to know the answer. What's the answer when you plug in 5 for every single x? All right, so what is f of 5? So here, okay, obviously I'm going to put a parenthesis, plug in the 5, another parenthesis, plug in the 5, and then now I've got my equation set up. So 5 squared is 25. This negative sign makes it -25. 6 times 5 is 30. Drop down the -4. And then the last step, you can drop down your f of +5, and then it's just simple math. -25 plus 30 is 5. 5 minus 4 is 1. And that's your answer. Number 6, and again, this is pretty repetitive, so it wants to know the answer. What is your answer of, meaning what is y when you plug in -8 for x? So that's why we get g of -8, because we're plugging -8 in for x. So -1/2, put in the -8, plus 9. So remember, all your math is on the right side. So -1/2 times -8 is +4. And then obviously your answer is 13. So when you plug in -8 for x, your answer is 13. All right. Number 7, it wants to know the answer when you plug in -5 for each x. So that's going to be f of negative 5. And then we're going to take out the x, put in a parenthesis, take out the x, put in a parenthesis, and then finish out the problem. Remember, exponents is going to be first because you can't do anything inside the parentheses. We've got to go by PEMDAS. Okay, parentheses, exponents, multiplication, or division, whichever comes first from left to right, and then addition or subtraction, whichever comes first from left to right. So, first thing right here, we've got exponents. So, negative 5 in parentheses squared is positive 25. All right? So now it's multiplication. Pretty simple. 2 times 25 is 50. And then 4 times negative 5 is negative 20. And then it's simple subtraction. Okay? 5 minus 20 is 30. Minus 9 is 21. So f of negative 5 is 21. Last one, number 8. So we've thrown in an absolute value here, but it doesn't work any different, okay? It still wants to know what is the answer when you put in negative 7 in for x. So it's going to be g of negative 7. All right, so I'm going to go ahead and put parentheses around this. Like so. So obviously we need to do what's inside the absolute value first. Negative 7 inside parentheses squared is positive 49. Now, the rest of it just drops down. So negative 7 minus 49 is going to be negative 56. And then the absolute value of negative 56 would be positive 56. And that would be your answer. You just drop the g of negative 7 down. And that would be your answer. So there's the first few problems at a glance. All right, number 9. Number 9 is a little bit more complicated. It wants to know what's the answer when you plug in f of c plus 7 in for x. So f of c plus 7 is going to equal 4, take out the x, put in the c plus 7, like so. Now obviously, still you're not doing anything on the left side. It just wants to know, the only thing that it's telling you on the left is you're plugging in c plus 7 in for x. That's all it's telling you. And then you're actually doing it on the right side. So it's telling you what you're doing on the left side, and then you're doing it on the right side. So meaning, obviously, we need to distribute here. So 4 times c is 4c. 4 times 7 is 28, and then drop down the plus 11. Combine like terms. 28 plus 11 is 39, so 4c plus 39. You cannot reduce that anymore, so when you plug in c plus 7 for x, your answer is 4c plus 39. And that would be your final answer on that one. All right. The next one. It wants to know, what's the answer when you plug in 2k minus 5 in for x? Whoops, went a little bit too far there. So here, I'm going to show that you're plugging in 2k minus 5 for x. And then on the on the right side, I'm actually going to do it. I'm going to plug in, all right, 2k minus 5 in for x, like so. All right? So again, remember what I said. It's showing what you're going to plug in on the left side, meaning I'm showing that I'm plugging in 2k minus 5 on the left. I'm actually plugging in 2k minus 5 on the right in for x. So on the right side, if you look at it, you've got a -1 here, okay, right next to the parenthesis. What is technically in front of that parenthesis? Yep, you guessed it. It's actually a -1. So you're technically going to distribute a -1, and you're just going to drop down the -9. So -1 times 2k is -2k. -1 times -5 is +5. Now what you're going to do is you're going to combine like terms. All right? So -9 plus 5 is -4. So you're going to drop down the -2k, and then once again, -9 plus 5 is -4. You cannot reduce that anymore. So when you plug in 2k minus 5 for x, the answer that you get is -2k minus 4. All right. Now this other side, okay? So on this first one, what it's showing you is it's saying f of 4 plus 9, okay? So obviously it's using the f of x equation, right? And it's saying plug 4 in for, f of 4 plus 9. So you're going to use this equation right here, f of x, because it's an F1. All right? So it's saying plug in f of 4. So you're actually going to plug in 4 in for x. So meaning you're looking for f of 4. So you're going to plug in 4. And then obviously, well, forgot the plus 9. So it's basically the equation that it's giving you, and then plus 9. Okay? So meaning you're plugging 4 in for x, and then you're plussing 9 on the end of it. Meaning you're using this equation, and then you're adding 9 because of that right there. So obviously we work it out. All right, so f of 4 is going to be, let's see, 8. Multiplication comes first, so that's going to be -12. So 8 minus 12 is -4. -4 plus 9 is 5. So when you plug in 4 for x, your answer is going to be 5, like so. And I'm going to go ahead and erase this part right here. All right, so it's saying it wants you to use g of -5. So we're going to use the g equation. Okay, so the g equation is g of x. Write a better x here. G of x equals x squared plus 2x. All right? And then it's saying we want you to plug in -5 in for x. And by the way, there's a -2 times in front of it. Okay? So meaning that's tacking on the times -2. So meaning, whoops, that times -2 is tacked on at the end. All right? So what it's doing is it's giving you the equation that it wants you to use. X squared plus 2x. And it's saying plug -5 in for x. But oh, by the way, we're adding, meaning we're tacking on times -2 with it. All right? So now we're everywhere where there's an x, we're going to put in -5. And then we're tacking on times 2 at the end. So now we solve. -25 inside parentheses squared is +25. All right? 2 times -5, okay, is going to be -10. And then obviously we do multiplication again first. So, and that's actually, I'm sorry, that's actually a -2. So drop down a -2. And then what we've got is multiplication. So -10 times -2 is +20. And so when -5 is plugged in for x in this equation, okay, obviously with a -2 multiplied with it, the answer is 45. All right. Now, number 13 is getting pretty complicated. Okay. So I'll go over it, but you're probably not going to be tested on this. So you can actually probably scroll on through this problem unless you're just curious and you want to see how it's worked. All right. So it's actually going to use the same equation twice because it's got g of 4 and g of -1. So what we've actually got is, on this one, we've got g of x equals, and then it's got the same equation twice. So g of x plus 2x, and then plus, because it's got a plus in the middle, right here. And then, obviously, the same equation, because it's a g. It's using the g equation. So everywhere where there's an x, all right, actually the first one, I'm sorry. So the first one, what you're going to do is you're going to plug in 4. Like so. The second one, you're going to plug in -1. Like so. All right. And then when you add these two g's together, and I'm just going to call it g of x, all right, because you're actually plugging in two different values, all right? So it's technically g of 4 plus g of -1. I'm just going to call it g of x, all right? The left side, remember, it's the same thing as y. So, you could actually put y here if you wanted. And actually that's what I'll go ahead and do. So, on the right side, exponents first. So 4 squared is 16. -1 in parentheses squared is 1. Multiplication comes next. So you've got, oh, that one went way up there. Okay, so we've got 2 times 4 is 8. And then 2 times -1 is -2. And then it's pretty simple math from right here. All right. What you're going to do is just add them up. All right. So 16 plus 8 is 24. Plus 1 is 25. Minus 2 is 23. And that would be your answer. All right, now, not going to do 14, 15, and 16 because, like I said, those probably are not going to be on your test. So I just wanted to do one example so you can see it, all right, worked out like so. But since I'm not probably going to put these on your test, there's no point in you watching the video of me working out these problems. It would be pointless and a waste of time, All right? So let's skip on down to number 17. All right? So number 17, it says, anthropologists use the length of certain bones of a human skeleton to estimate the height of the living person. One of these bones is the femur. To estimate the height in centimeters, if a centimeters of a female with a femur of the length of X. The function, so it gives you the function, and it says it can be used and find H of 46. So again, we've done this several times. Wherever there's an X, it's telling you put in 46 in for the X. So wherever there's an X, you're going to put in a 46. So obviously multiplication comes first. 2.32 times 46 is going to be 106.72. And then you add them together, you get 168.13. So when you plug in 46 in for X, you get 168.3 centimeters. Last part, number 18. What it's saying is, and this is actually pretty easy. A lot of people make this a lot harder than what it is. It's saying when X, so look at A, when X is negative 3, what is your Y? So let's go where X is negative 3. So negative 1, negative 2, negative 3. Now, I need to go up where it actually hits the graph. This is where it actually hits the graph. Okay? So when my X is negative 1, 2, 3, what is my Y? 1, 2. So my Y is going to be 2. Meaning you actually have to find where the graph is. All right? So the next one, B. When X is 1, okay? So I'm going to actually erase these dots right here. I'll leave the other point. When X is 1, right here, what is Y? Well, here's the graph right here. So when X is 1, Y is what? Y is going to be 2. Because you count up 1, 2. C. When F is 0, what is Y? 1, 2, 3, 4, 5. So when X is 0, Y hits the graph at 5. D. When X is 2, so go over 1, 2, where does it hit the graph? It hits the graph down here, right here. And that's at negative 3. So when X is 2, your Y is negative 3. And I'll go ahead and erase this whole entire graph now. That way we're kind of looking at just the graph. So that would be 18. All right, let's go to 19. And this will be the last problem for these notes. Okay, pretty sure. Yeah, last problem for these notes, 19. So when F is, meaning when F of X, so when when X is negative 4, so count left negative 4, 1, 2, 3, 4. What is your Y? Well, here's where the graph hits, right? So Y is going to be 2. All right, next one. B. When F, meaning when X is 0, well, Y is also 0. When X is 2, so count right 2. What is your Y? Well, it hits down here, right? So Y is going to be negative 2. And then last but not least, when X is 5, so count 1, 2, 3, 4, 5. Where is the Y? It hits right here at negative 1. And there is your problems at a glance. That is function notation and evaluating the function.